So in today's video, we're going to learn about negative exponents. But before we talk about negative exponents, let's just talk about a simple basic exponent. For example, let's just add 2 to the power of 3. Well, what does that mean? Well, it means 2 times 2 times 2 3 times, because 3 tells you the number of times to multiply the 2. If you have 2 to the power of 2, you end up getting 2 times 2, which equals 2, 4. And now, if you have 2 to the power of 1, what does that give you? It's just 2 by itself. The next thing we're going to go is, well, a negative exponent. Well, what does a negative exponent look like? So we'll start off with a very simple negative exponent. So an exponent has a negative number. Now, let's actually use our calculators to evaluate this first. If you put this in your calculator, so how are you going to put this in your calculator? You might have this button on your calculator, or you might have this little pointy thing on your calculator. It depends on the name brand. If you put this in your calculator, you get 0.5. And you're probably wondering, well, how is 2, negative 1, and the digit 5 or 0.5 related to each other? Like, I see no direct relationships. However, 0.5 can be written as 1 over 2. So now we can see that there's something going on here with the 2 involved. But is that a coincidence? Well, let's open it up. Let's actually look at 4 to the power of negative 1. You put this in your calculator and you end up getting 0.25, a quarter. And 0.25 is the same thing as 1 over 4. Notice how there's a direct connection between base 4 here and the denominator 4 here. So in these two specific examples, somehow there's something going on with negative exponents and somehow fractions starting to appear. But of course, I'm just taking very specific examples because I'm actually taking to the power of negative 1. So the question is, what happens if we change the negative 1 into something else? So let's actually look at 2 to the power of negative 2. For example, so over here to the right hand side, 2 to the power of negative 2 is equals to 0.25 if you put it in the calculator. And you might think, well, I don't see anything going on between the digits. It seems like 25 or 0.25 has nothing to do with the exponents here, or the base and exponent. But 0.25 is the same thing as, in fractions, 1 over 4. And you're probably wondering, well, how is 4 related to any of the base and the exponent? Over here, and then the negative exponent. So the question right now is, how is the negative exponent related to the numerator and the denominator, the fraction form? So I'm going to show you a couple of ways, 2 examples or 2 perspectives of how negative exponents are related to each other. I mean, in this particular slide, maybe you might figure out how they're related to each other, because at the very end, I'd like everyone to know how to do the following. What is x to the negative 2? How can you express this differently? Or for example, 2 over 3 to the power of negative 3. How can you express this in a different way? Or if I say 5 to the negative 2, can you express this in a different way without using a calculator? Okay, so I'm going to start off with a contextualized question, like a word problem. So it says here on day 0, which is over here, you got $1, okay? And I'm going to give you a condition that every single day that moves on, so the next day, your money is going to double. So this dollar is going to double. You got 2. Now the next day, the amount of money that you have over here is also going to double. So what's going to happen is that everything is going to double. Double 2 is 4, double 4 is 8, double 8 is 16. So what's happening is, it seems like we're always multiplying by 2 times 2 times 2 times 2 as we keep on going through the days. Now the question right now is, well, what is happening backwards? So you might think, well, miss, time has to be positive. Well, time is actually relative. So if this is today, that means this is going to be yesterday. In this case, this is going to be negative 1. So 1 day before today, negative 2, and negative 3. So we can go back in time, assuming that time is relative. So what happens to the pattern here? Well, instead of multiplying by 2, well, you should have more or less money the day before. You should have less, but by how much? You're going to be half. So this is going to be 0.5. So that means when we go backwards in the pattern, we're not going to multiply by 2, we're going to divide by 2, because the previous days we should have less. This becomes 0.25. So this one you have 50 cents, 25 cents, and here you have 12-ish cents. And I might as well talk about this now. In the past, in grade 9, you probably had something called first differences, where there was a pattern where you add numbers to get to the next number. Well, this is not adding to get to the next number. This is actually multiplying or dividing to get to the next number. We call this ratios. And we'll talk about this in the next couple of videos later on, but I'm just going to introduce that in word ratios. Okay, so the question right now is, Miss, how is this related to exponents? Miss, I don't see any exponents at all. So let's look at the numbers on the right-hand side. I'm going to circle them in green. Now, is there any way, since we're talking about exponent form, how can we express 4 in terms of an exponent? Well, we can know that 4 can be expressed as 2 to the power of 2. 8 can be expressed as 2 to the power of 3, because 2 times 2 times 2 is 3. 16 is 2 to the power of 4. And this one here is single, meaning it's 2 to the power of 1. So do you see the pattern going on with these numbers, the green numbers? And what's interesting about these numbers, let's look at these numbers here. How is 1 connected to this? Oh, it's related to the exponent. How is 2 connected to the money? Oh, it's connected to this. How is the third day? So this is day 3, 3 days after. And how is that connected to this format? Oh, so it seems like the number of days is actually sort of like formatted into the exponent part. So if I were to continue this pattern, let's just say I wanted to go to day 11. Well, after 11 days, how much money would I have? Well, based on this pattern over here, you would write 2 to the power of 11. And if you put that on your calculator, you're going to get a huge number. So that's the pattern going on. And that's how exponents are related. Now, let's actually talk about negative exponents. Let's go back. So we're going to take this pattern and move backwards. So let's go to the 0. On day 0, what's going to happen? Well, you got 2 to the power of 0. So this is the first time for us encountering a 0 exponent in grade 11. Maybe some students have already seen this before. Let's go back to the pattern. What happens yesterday? Well, we have 2 to the power of negative 1. So we're actually using exponent form and continuing the pattern. 2 days before, 2 to the negative 2. 3 days before, 2 to the power of negative 3. And if you notice all these numbers that we got, including the decimal place, we didn't even need a calculator. So right now we're going to compare the negative exponents. So I'm going to just copy this one down over here. So we actually saw this in the previous slide. 2 to the power of negative 1 is 0.5, 50 cents. 50 cents can be written as 1 over 2. 2 to the power of negative 2 can be written as 1 over 4. However, what's interesting is 1 over 4, this 4, based on this 4 here, can be written as 2 to the power of 2. I want to involve exponents. Here, 2 to the negative 3 will give you 0.125. The question is, if you were to not rely on your calculator, we know that 0.25 is the same thing as a quarter. And if you go back in time, you're going to have to divide by 2. So what is actually a quarter divided by 2? Well, remember, a quarter divided by 2 is the same thing as 1 over 4 times the reciprocal, and that becomes 1 over 8. In other words, this one here is the same thing as 0.125, 1 over 8. And how is 8 related to exponent? Well, 8 is over here, right over here in blue. It's become 2 to the power of 3. So do you see a pattern going on with negative exponents? So it seems like the negative exponents somehow refer to the reciprocal, meaning it's 1 over something. In other words, and if you notice here, the exponent form goes into the denominator right now. So it's pretty much the same thing. However, the negative actually sort of dictates the format, meaning it's going to be 1 over something, 1 over something. So if I were to say 2 to the power of negative 12, okay, so you would have a fraction. This whole thing, the exponent format, base exponent, would be in the denominator. However, this negative actually indicates that you're going to take the reciprocal. So if I were to generalize this, 2 to the power of negative n equals 1 over 2 to the power of n. Or even actually more generalized, let's call it base to the power of negative 1. So negative n. So this is exponent form, base exponent. And if you have a negative exponent, all it means is just you take the reciprocal of the exponent. Reciprocal of the exponent form. You do not put a negative here because you already addressed the negative exponent. So in this example, it's going to be the other way around. Instead of you doubling your money every single day afterwards, your money is going to be cut in half. So in other words, everything is going to be divided by 2. Divided by 2. Or we can say multiply by half. Whatever happens to the next day, you're going to cut everything in half. In other words, your ratio, this brand new word we talked about in terms of exponents, you're going to half everything. So here's $1. What happens to the dollar? You're going to get 50 cents. Instead of calling it 50 cents, I'll put here, I'm going to put it in a fraction, 1 over 2. This one here, you get 25 cents. But in this case, I want to change it to a 1 over 4, 1 over 8, 1 over 16. So you're multiplying the fractions by 1 over 2. Now, as I said again, well, how is this related to fractions? Well, I'll put here on the side, 1 over 4 is the same thing as 1 over 2 times 1 over 2. In other words, it's the same thing as 1 over 2 to the power of 2. So this one here, 1 to the power of 2 half square. Now what's 1 over 8 the same thing as? Well, it's the same thing as 1 over 2 times 1 over 2, because remember when you multiply fractions, you should multiply the denominators 3 times. In this case, it'll be 1 over 2 to the power of 3, because we're multiplying the same half 3 times. So over here you have 1 over 2 to the power of 3, and the same thing 1 over 2 to the power of 4. So here we have a base. So the base right now is not like a single digit. So it's not like a whole number. It's actually a fraction. And here's your exponent. Over here, we go backwards in time. This is the same thing to the half. So notice how there's a pattern going on between the independent variable, the days, versus the exponent. You have 2 days. Oh, the exponent is 2. 3 days. 3, 4, and 4. We're going to continue this pattern. This is 1 to the power of 0. We will talk about zero exponents later on, but you will notice on the previous example, on 0 day you had $1. Anything to the power of 0 is going to be 1, and I'll show that more algebraic wise in the next slide. Let's go back in the pattern. So over here, the pattern here is, let's go back in time. I have -1 here, 1 day, 2 days, and 3 days ago, and we continue the pattern. 1 over 2 to the power of -1. 1 over 2 to the power of -2, and 1 over 2 to the power of -3. And we're not going to use calculators to actually do this, all right? We know something about the pattern. Now, what do you mean? Well, when we go back in time, what happens? Well, instead of dividing by 2, we're going to actually multiply by 2, because yesterday you should have more money than today. So in other words, this dollar here, I'm circling, is going to be doubled because we're going back in time. So this actually equals to 2. You keep on going. What's double 2? 4. What's double 4? 8. So in other words, we can see right here in yellow that there is a pattern going on with the exponents, fraction exponents, and the number. So let's recap what we did in the first slide. So recap that, if I say 2 to the power of -1, so let's say 2 to the power of -3, that means you take base exponent, you put it directly in the denominator, and this negative indicates there's going to be a reciprocal. You're flipping, okay? So we generalized this before, so we're going to generalize this. So here's your base exponent. So the base and exponent goes in the denominator, but this negative tells me you're going to put it over 1. Now the base could be whatever number you want. It could be like a fraction, it could be like a whole number. Now let's actually look at this example here. 1 over 2 to the power of -1 is equals to 2. So I'm grabbing this one over here. I'm just going to rewrite it out. So let's just say you didn't know that 2 was the answer. Well, how would you apply this rule that we just talked about up here, over here, and use it? Well, it's the same thing. You have the base and the exponent. That goes in the denominator, the whole base, which is a half, and the exponent goes in the denominator, but this negative indicates there is a reciprocal. And you're probably wondering, Miss, this looks even more complicated now. Well, not really, because when you divide a fraction, so this is the same thing as 1 divided by 1 over 2 to the power of 1. And we know anything to the power of 1 doesn't really change much, which is 1 over 2. And how do you divide fractions? Well, you multiply by the reciprocal. In this case, that gives you 2. And that's how we do this. I'm showing you all the steps. Well, what happens to 1 over 2 half to the -2? It's exactly the same. So we have the base, which is a fraction. You put the exponent form. You don't put the negative, because the negative sort of tells you, it tells you that there is a reciprocal. And then you do all the same work. You end up getting 1 divided by 1 over 2 square, and that gives you 1 times 2 over 1 square, which gives you 4. And you will come to realize what's interesting about this is, if you take a reciprocal of a fraction, all right, so if I ask you right now, let's just focus on 1/2. What's the reciprocal of 1/2? Well, instead of 1 over 2, it becomes 2 over 1. So notice here in both cases, they actually flip. So if we're to generalize this, let's actually get some room in the bottom here. If I say you have, for example, 3 over 4 to the power of negative 2, okay? We're going to use a different example. Well, to do this without, you don't actually have to show all the steps here. You can if you wanted to, but here's another way. Because this here indicates you're going to have to flip, meaning you're going to have to take the reciprocal. Instead of 3 over 4, you get 4 over 3 and then to the power of 2, because this negative means you're going to take the reciprocal, and then you already took the reciprocal, and now you maintain the square, and that becomes what, 16 over 9, because 4 over 3 times 4 over 3 is equals to 16 over 9. So to generalize fractions where the base is a fraction, I'm going to just write the following. If I have a over b to the power of negative n, okay, there's a couple of ways. If you wanted to, you can take the long root, meaning 1 over, so the negative indicates that there is a reciprocal. You can put a over b to the power of n, okay? You can take 1 divided by a over b just to rewrite it out. And you know when you multiply, divide by a fraction, you're going to have to take the reciprocal of this, and then you end up getting b over a to the power of n. So in other words, if you notice I'll call it a proof here, notice the beginning of the story and the end of the story, they look the same. The only difference is that the negatives are gone because you took the reciprocal. So going back, if I were to give you, for example, 5 over 2 to the power of negative 2, well, I don't have to show all my steps here. I can just go directly to the end, meaning I have to the power of 2. It's still a base and exponent form. It's just your base is flipped. And if I ask you to evaluate, well, we know that squares, you're going to multiply it twice, you get 4 over 25. So in this particular perspective, we're going to look from an algebraic point of view. So in the previous example with the money doubling or halving, we're actually using real numbers and looking at patterns of numbers, patterns of formats. It was all pattern based, and we're using numbers. Now this particular case, this perspective, we're going to actually use variables and review and use the exponent laws that you've learned before. So let's talk about multiplying. So when you multiply, for example, x2 times x3, well, what do you do with exponents when you multiply bases that are the same? Well, you just add them and you get x to the power of 5. Now what happens if you subtract? Let's just say I have x5 divided by x2. What do you do with exponents when you divide bases that are the same? Well, you would subtract them. That gives you x3. Now this question here can be written differently. It can be written as a fraction form. And when you do fractions, just to show you all the expanded form, I have 5 x's at the top and 2 x's at the bottom. And based on what we learned before, especially in rational expressions, we can start to reduce. So x divided by x divided by x. And what are we left with at the end? Oh, we're left with 3 x's. Notice how we have 2 different formats, 2 different beginnings, and we end up with the same answer. So, how are negative exponents involved, miss? I only see positive exponents. Well, what happens if I change this other way around? Let's just say I did x2 divided by x5 to the power of 5. Well, you do the exact same thing. You have 2 minus 5. However, what's 2 minus 5? It gives you negative 3. Now, another perspective is, let's actually write this out in the fraction form. So I have 2 x's on top and 5 of them at the bottom. And after I write all of them out, we can start to reduce. Gone, 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 gone. Now, when something is gone, there is still a number in the numerator. It's a 1. And how many x's do we have left? X to the power of 3. So now, if you notice, we have 2 different answers. They're both correct, but they don't look the same. The format is not the same. However, I'm going to put them together. Ooh. So remember what we did before? So this is actually a way to express a negative exponent from an algebraic point of view. No numbers, just using exponent laws. So we can use this format and sort of open it up to x to the power of negative n. What does that give us? Oh, x to the power of n, the reciprocal. So similar idea, but more direct algebra. So now I'm going to actually focus on zero exponents, because in the previous examples using the money, it seems like on day 0 we had $1. it seemed like, for example, I think we had, for example, 2 to the power of 0, that gave us 1, or 1/2 to the power of 0 gave us 1. And if you put that in your calculator, you also get 1. But this just to show you from an algebraic point of view. So over here, I'm going to do the exact same question. So let's call it b to the, let's call it n, divided b to the n. Okay? And what happens when you divide something with same bases? Well, you subtract the exponents. N minus n is equals to b to the power of 0. So here we have an exponent form. Okay? Now, however, if I were to express this in terms of a fraction form, well, what do you notice? Well, this is the, if I were to write this out in expanded form, we have the same number of b's on the numerator and same number of b's in the denominator, and pretty much they will all go away. So simplify, what does that give us? It gives us 1/1, which eventually gives us equals to 1. Because identical divided by identical will always give us 1. And if you apply the exponent rules, subtraction rules, we get b to the power of 0. So we have same answer, but two different looking formats. In other words, b to the power of 0 will equal to 1 always. So this is just more like an algebraic demonstration or proof, you could say, to show that anything to the base 0 is going to be a 1.